I'm back. Part 2 of trigonometric integrals. Here we go. Now we just did sine and cosine integrals. Now it's time for secant and tangent integrals. Oh yeah! Okay, so the integral of tangent to the 6x times secant to the 4th x dx. Now we're going to do the similar thing, except for the fact that with sine and cosine, the derivative of sine is cosine, the derivative of cosine is minus sine. So what we were trying to do is squirrel away a single sine or a single cosine. Well, now the derivative of tangent is secant squared, and the derivative of secant is secant tangent. So what I'm trying to do is I'm trying to squirrel away a secant squared instead of just a secant or a tangent. So notice I can do this here. What I'm going to do is I'm going to say, since we'll just go right to the u substitution. So we're going to let u equal tangent x. So that means du equals secant squared x dx. Okay, now what I can do is I can rewrite this with the secant squared dx part right there. But now there's one more thing. We're going to have to change the secant that's left over into a tangent. Well, how do we change secant to tangent? Well, we know that secant squared minus tangent squared equals 1. S comes before t, and there's a minus there. So now what that means is that the u is tangent, so we want everything in terms of tangent. So what I do is I say secant squared x equals tangent squared x plus 1. Okay, so that gives me the integral of, now I'm going to keep my tangent to the 6th x. Now this secant to the 4th is going to be a secant squared times secant squared. So the secant, well, let's just write that. Secant squared x times secant squared x dx. Now notice my du is right there, secant squared x dx. But I need to get this other secant squared into the tangent. So I have the integral of tangent to the 6 times tangent squared plus 1 times. Okay, so now we're ready to go. We have all tangents except for the secant squared x dx that we squirreled away. So now we can say let u equal tangent x. So that means I have the integral of u to the 6th times u squared plus 1 times secant squared x dx, which is the du. So I've gotten rid of all the secant tangents. All I have is nice friendly u's. So u to the 6th times u to the 2 is u to the 8th plus u to the 6 times 1, which equals u to the 9th over 9 plus u to the 7th over 7 plus c, senor. Okay, so our final answer, we're going to put our tangents back in here. And so this whole thing equals tangent to the 9th x over 9 plus tangent to the 7th x over 7 plus c. Okay, so notice this is the exact same thing that we did with sine and cosine, only we had to squirrel away a secant squared instead of just a sine or a cosine, and we turned everything into tangents. All right, so let's try another one. Let's try another one. It's not ready yet. There we are. Okay, so integral of tangent to the fifth secant to the seventh dx. Now, I have odd exponents. So what I'm going to do now is I'm going to squirrel away a secant tangent dx. So notice this is going to equal the integral of, I like having, I will leave it this way. So tangent to the fourth times secant to the sixth times secant tangent dx. Now, why did I put a secant tangent dx at the end? Because when I do my u substitution, u is going to equal secant x. So that means du equals the derivative of secant, which is secant tangent dx. Well, there's my secant tangent dx. And so the only other thing is, if u is going to be secant, then I don't want any tangents. I want all secants. So remember, secant squared x minus tangent squared x equals 1, which means that tangent squared x equals secant squared minus 1. Okay, so I go to all my tangents and I change them to secant squared minus 1. So I have integral of tangent to the fourth. So that will be secant squared minus 1 squared. There's my tangent to the fourth. Times secant to the sixth times my du in the future. All right, so now I'm ready to turn all the secants into u's and the secant tangent into du. So this whole thing equals the integral of u squared minus 1 squared times u to the sixth du. So this equals a squared minus 2ab plus b squared so I distribute my u to the sixth and I end up with u to the 10th minus 2u to the 8th plus u to the 6th du. And so this is going to equal u to the 11th over 11 minus 2u to the 9th over 9 plus u to the 7th over 7 plus c, senor. Now I go and put secant x back in, so my final answer is secant x to the 11th over 11 minus 2 secant to the 9th over 9 plus secant to the 7th over 7 plus c. That's it. Let's see. Did I do that right? It appears I've done it right. All right, that's enough. Okay, so let's recap our secant tangent integrals. So when I have secant m tangent n, if m is even, then what I'm going to do is I'm going to squirrel away some number of secant squareds. And then all the rest of my secants are even. And so I can let u equal tangent x, and then everything becomes something in terms of tangent. So I change all my secant squareds into tangent squareds plus 1. Now, if n is odd, m and n are both odd, then I'm going to squirrel away a secant tangent, and then all the rest of my secants and tangents are even, so I let u equal secant, which makes du secant tangent, and then I turn everything into secants. So all my tangents become secant squared plus 1. Or, I'm sorry, secant squared minus 1. So, that's it. Now, two things that you want to memorize that won't be covered in this. The integral of tangent is natural log absolute value of secant plus c. The integral of secant is natural log secant plus tangent plus c, absolute value. Now, this is not, okay, let's just go one more step here. I'd go the derivative of tangent is secant squared. So the integral of tangent is natural log secant. And the derivative of secant is secant tangent. So the integral of secant is natural log secant plus tangent. So there are some similarities here. It's not a proof that these work, but it's a memory peg. If you remember the derivative of tangent secant squared, integral of tangent has secant in it also. And if you know derivative of secant is secant tangent, then the integral of secant has secant and tangent in it. Now, you just have to remember that the integral of tangent and secant is both natural logs, and then you've got integral of tangent natural log secant, integral of secant is natural log secant plus tangent. Now, I'm not sure if you're familiar with this terminology here. Memorize. That means make sure that there's never a time that you don't know that.
That's the smartest thing I've ever heard anyone say about anything.
Yes. Okay. So, let's cruise onward to just a couple of more of these secant tangent integrals that don't fit into the formula, like tangent cubed x. Okay, now, what we want to do with tangent cubed is we want to break it up into tangent and tangent squared. Now notice, if I've got tangent x, well watch, if I change my tangent squared into secants. Now remember, secant squared minus tangent squared equals 1. So that means tangent squared is secant squared minus 1. Okay, so now what I have is integral of tangent secant squared minus the integral of tangent. So let's just go secant squared tangent minus the integral of... Okay, so the integral of secant squared times tangent let's see, secant squared, yeah, this is where it gets fun. Oh, yeah, okay, that's easy. Man, it's staring you right in the face. And I wrote it backwards, which made me not see it. So let's write it forward. Okay, notice, what's the derivative of tangent? It's secant squared. So we'll just do the step here. We're going to say let u equal tangent x. So that means du equals the derivative of tangent secant squared x dx. So there we have our secant squared x dx. So now this thing becomes the integral of u du minus the integral of tangent x dx. Now, u du is going to be u squared over 2, and the integral of tangent x, we just learned that, is natural log of secant x plus c, senor. Okay, so we need to put the x's back in, so this becomes tangent squared x over 2. Let's just reciprocate the secant, and we get cosine. And so what I did was I took the -1 here, put it up here as the exponent. So this just cleans it up. I like cosine better than secant, and I like pluses better than minuses. So that's it, game over. And let's just make sure the book agrees with me. Well, it does, but it didn't see my ingenuity here to get cosine. So I like my way better than the books. Okay, so notice all we did here was we broke up our tangent cubed into tangent times tangent squared, changed our tangent into secant squared minus 1, and then we ended up with two integrals. One was an easy u substitution, the other was the one we memorized, and so it's all happy. Okay. One last one. Yeah, this is definitely the last one. Okay, now we're going to do the same type of thing here with the secant cubed, is we're going to break it up into parts. Yeah, okay, so it's going to be secant times secant squared. Now watch the magic. We're going to let u equal secant x, and then dv equals secant squared x dx. Secant squared x dx. Okay, now, that makes du, the derivative of secant, is secant tangent. And dv will make v the integral of secant squared, which is tangent. Okay, now we're ready to apply our integration by parts. So integral of u dv equals uv, which is secant tangent, minus the integral of v du. So tangent times secant tangent. So tangent squared, oops. Let's just leave it like this. Tangent times secant tangent. Okay, so this is uv minus the integral of v du. Okay, now we've got tangent. Okay, I think what we're going to do is change our tangents into secants. Let me just make sure. Yeah, okay. So we've got, come on, okay. Now, I've got secant times tangent squared. Now, tangent squared equals secant squared minus 1. Okay, so there's my secant times tangent squared equals secant times, secant squared x minus 1. Okay, so secant tangent squared equals secant times secant squared minus 1. Now, this equals secant tangent minus the integral of secant cubed plus secant. You know, let's do it like this. Now see, we have a minus, and this is secant times 1. Okay, so I broke this one integral up into two integrals because it's secant cubed minus secant, but minus is plus. Okay, now let's evaluate the secant x. So this equals secant tangent minus integral of secant cubed plus the integral of secant, which is natural log secant plus tangent. Plus c, of course. But we'll do the plus c at the very end. All right, now, any ideas on what we should do at this point? Notice I have a secant cubed here. So what we're going to do is that same trick I showed you a little while ago, and that is let the integral of secant cubed equal I. That means what we have is I equals secant tangent minus I plus natural log secant plus tangent. Okay, so we're trying to find out what I equals, what the integral of secant cubed is. So we add that to the other side, and we have 2I equals secant tangent plus natural log of secant plus tangent. So that means the one integral equals 1/2 secant tangent plus 1/2 natural log secant plus tangent plus C at the very end. That's it, game over. Let's see if we got it right. So 1/2 secant tangent plus 1/2 natural log. Yes, we got it right. So that's it. Have fun with these.